Hi everyone, my name is Lydia and this is what I wish they had taught me about econometrics and introduction. In the previous video, we saw the mechanical properties and we looked into detail on the proofs of the first three mechanical properties. In this video, we'll concentrate on the last two mechanical properties and their proofs. The fourth mechanical property is that the sample dependent variable mean is equal to the mean of the fitted OLS values. Mathematically, we would write it as y bar being equal to y hat bar. The fifth mechanical property is that the OLS fitted values are uncorrelated with OLS residuals, and we will write that mathematically as the sum of yi hat times epsilon I hat being equal to 0. Now that we have written the mathematical expression for both the mechanical properties, let's dive into the proofs. Just a quick reminder, for the proofs for the fourth and fifth mechanical properties, we are going to extensively use the knowledge that we have on the properties of the summation operator. So if you don't remember them, or if you have skipped our video on revision of the properties of the summation notation, make sure that you check the video out. So without further ado, let's continue to the proofs. We will start from the fitted values. Identity that we have seen so far, where we know yi hat is equal to beta null hat plus beta 1 hat xi. If we sum both sides, then we will have the sum of yi equals to sum of beta null hat plus the sum of beta 1 hat xi. From here, we know that the sum of a constant is simply n times that constant. And we can send the constant in front here, so we can rewrite this beta 1 hat as the sum of xi. At the same time, we also have an expression from beta null, which we can basically use from either mechanical property 3 or which is literally the fact that we know now that beta null hat is equal to y bar minus beta 1 hat times x bar. Okay, so we're using mechanical property 3, which in a sense it's basically what we found as an end result for the beta null formula once we solve for the first order conditions. If we substitute this expression now in the expression that we're looking into, we can continue rewriting this as the sum of the yi's, 1 to n times y bar minus beta 1 hat x bar plus beta 1 hat. Now, keep in mind, using the summation properties, we can write this as n times x bar. Once we take things out of the bracket, we'll see here that the sum of yi is equal to n times y bar minus n times beta 1 hat x bar, and then we've got here beta 1 hat and x bar. These two terms cancel each other out, and we can use the average formula also on this side, and we can rewrite these simply as n times y bar equal to n times y bar. And here, let's add the hat. Sorry, I have forgotten to add it in all of our part here, so that means the hat should stay over here as well. The n cancels out, and finally we have what we were looking for, that the average of our fitted values is identical to the average y. This was a little bit longer, and it required us using other mechanical properties as well, but once you know the process, it becomes pretty straightforward. Now let's move on to the proof of property 5. Property 5 told us that the sum of our yi hat, so the fitted values, times the residual is equal to 0. So let's see if this is indeed the case. Remember, we know that yi hat is equal to beta null hat plus beta 1 hat xi from our fitted value expression. So if we substitute now this into the original mechanical property expression, we will get that we have the beta null plus beta 1 hat xi times the residual. From here, we can distribute the brackets, and we will find that this is beta null hat times the sum of the residuals plus beta 1 hat times the sum of xi times the residuals. Now notice very carefully. Here, we can use mechanical property 1, and we know that this is going to be equal to 0. Notice also that this bit right here will come from mechanical property 2, which tells us that this is also 0. Which means overall, now we know that we have an expression that is equal to 0. Let's see the proofs with the worked example. We're going to use exactly the same numbers that we had in our previous video. We already know now the y hat, the epsilon hat, and x bar and y bar. So let's dive in directly into making the computations. We did an actual proof for mechanical property 3 by checking the math, but since we have computed the y hats in here, we can very easily see that our y hat bar is going to be just 4.5, and that would serve as a proof for our mechanical property 4. Now, for proving mechanical property 5, we would have to take the sum of the product of the y I with the residual, which means that we're going to have 3.3 times minus 0.3 plus 4.1 times 0.9 plus 4.9 times minus 0.9 plus 5.7 times 0.3. And if you do the computations, you will easily find that this will be equal to 0, meaning that mechanical property 5 also holds on. These two results will complete the mechanical properties of OLS in scalar interpretations. All 5 properties, as you saw, came straight from the first order conditions, and they are true for every dataset, independent of any assumptions. In the next video, we'll move to the matrix mechanical properties notation, so that for those of you who are using books that use more the matrix notation, these mechanical properties will make even clearer the projection geometry concept that we have seen in previous videos as well. See you in the next video.